But before we get started, are there any questions over the homework? Any of the homework assignments we have had thus far? Now, I did tell y'all yesterday that section 4, 4.1, and 4.2 were going to be bonus and their assignments attached to them, all in Google Classroom. One thing I did forget to tell you was over there on the bookshelf, those two packets of notes are 4.4.1 and 4.4.2. So y'all already have 4.4.1. If you want to get the 4.4.2 notes, they are over there. So did forget to tell y'all that. Now, what I want to start with today is the rational root theorem. You can leave that cracked for a minute. And this here is helpful for solving higher degree polynomial functions. Because as we've seen already, the graphing calculator is very helpful because it can give us solutions straight out, because whatever value of x makes the function equal 0 will work for it. This theorem here, the rational root theorem, for any polynomial function that has integer coefficients, will give us every rational solution in the form p over q. So it'll give us every rational 0. Now the main thing I would have down for this theorem is this part here. And we do need plus or minus. Plus or minus p over q. Huh? I do not know. Okay. So, P is the factors of the constant term, so our term without a variable, and Q is the factors of the leading coefficient. So, in this here will give us all the possible rational zeros, so anything that we can write as fraction. And this can be very helpful, especially if the solutions that we have for a given equation aren't integers, are nice numbers that the graphing calculator will tell us outright. So the first one that we're going to look at with this is this problem here. And we want to find the rational zeros, or plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient. Now our constant term in this equation here is the term without x. So factors of 20, which, well, the first ones would be 1 and 20. So we'd have 2 and 10, 4 and 5. So we're just listing out all the numbers that multiply together to give us 20. Questions on this so far? Be good with the factors of p. Yes. Factors of q is factors of the leading coefficient. Leading coefficient is the number in front of the variable with the biggest exponent. Well, since the number is not written, it's understood to be 1. Well, all the factors of 1 are just 1. So now that we have these listed out, we're going to do all the factors of p divided by all the factors of q. We good?
We were finishing.
Okay. Okay. Now, so all the factors of p divided by all the factors of q. So we're going to start with one q at a time. Well, for this one here, we only have one value of q. So we'll start off with plus or minus. 1 divided by 1 is 1. Plus or minus. 2 divided by 1 is plus or minus. 4 divided by 1 is 4. Then we will do 5 divided by 1, plus or minus 5. 10 divided by 1, plus or minus 10. And lastly, 20 divided by 1 is plus or minus 20. Now with the rational root theorem, we'll always get kind of this form here, plus or minus all the factors of p, because the first number we have to divide it by is 1. Now if we had another value of q, let's say 3, we would do this again, plus or minus 1 divided by 3, plus or minus 2 divided by 3, 4 divided by 3, 5 divided by 3, 10 divided by 3, and 20 divided by 3. We would just keep going through all the values of q. And if there are any that are repeated, that show up more than once, and most of these would be if q was, say, 2, 2 divided by 2 is 1. We already have it listed. We're not going to write it twice. But all of the rational zeros for this higher degree polynomial function are listed here. 1, 2, 4, 5, 10, and 20. So P would be all the numerators, Q would be the denominators. And I do find it easier to go with the first, divide everything by the first value of Q and then going on, because if there are repeated terms, we'll see them as we increase Q. And we'll do another one where we do have Q as something other than just 1. So I'm going to erase P and Q here so I have a little more room to work. But now we're going to solve. Now the pure mathematical way to do this is, again, we're going to be using synthetic division. And we're going to start with the first rational zero that we have, positive 1. Now the numbers going across the top are the coefficients in front of our variables. So 1 for x cubed, negative 8 for x squared, 11 for x, and 20. We bring the 1 down. Now we know 1 is a solution, and it works if the remainder is 0. So we'll work through this here. Well, 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. 11 plus negative 7 is 4. 1 times 4 is 4. And 20 plus 4 is 24. So the remainder for this one here is 24. So it's not 0, which means 1 is not a solution. Has to be 0 to be a solution. Okay, well, now we can erase all that there. Well, now we can try 2. 2 times 1 is 2. Negative 8 plus 2 is almost negative 6. 2 times negative 6 is negative 12. 11 minus 12 is negative 1. 2 times negative 1 is negative 2 plus 20 is, so didn't give us a remainder of 0, which means not a solution. Okay. We're going to try 5. 1 times 5 is 5. Negative 8 plus 5 is negative 3. 5 times negative 3 is negative 15. 11 plus negative 15 is negative 4. 5 times negative 4 is. So it tells us x is 5. Now one thing that is nice is that we saw that 1 and 2 don't work. And if they don't work at one point in this process of synthetic division, they're not going to work again. There's no way, and I'm going to write this out. I would suggest that y'all don't write this synthetic division down. Because if we tried 1 again, 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2. It still doesn't work. If it didn't work first time, it's not going to work in any additional ones. Now 5 could work again if 5 was a repeated solution. So if 5 worked twice, it would work again. But if it doesn't, and I can show you this here, because it's not repeated, 5, 2, 10, it won't work. Because every time we do the synthetic division, we remove that solution from the remaining ones that we have left to find. Since 5 only worked once, we can see here it doesn't work a second time. But now we still have 4, 10, 20, negative 1, negative 2, negative 4, negative 5, negative 10, and negative 20 still to try. Okay. But that's still a lot to check.
The internet is down. Fiber has been cut. No ETA on repairs yet. Phones will be down too. The post has been made for parents to know the emergency number to call if they need to reach the school. Thank you.
Now at this point here, we could plug it in as a quadratic and solve from there. Or what we could have done from the beginning is type this into the graphing calculator. X to the third minus 8x squared plus 11x, is it plus 24?
Plus
20, that's it. And once you get it typed in, hit graph.
Oh, yes.
Well, so you might have to clear out the original one. Well, here there's 3. There's 3 for this one here. Graph. So we have this here. Yes. Second graph will give us a table. And if we look at this here, one of the values we already found was 5, yes? It showed up. But we also have another one which is and. Okay. Those are our 3 solutions. Well, if it gives us all 3, here we needed 3, it gave us 3, so we're done. We don't need to find any more. But if it does not give us enough solutions, then we will have to go and find them. That should be 1. Luckily, we'll get that with 4, 6, but there is a way to tell. And that comes with the fundamental theorem of algebra. Now, well, here we can check and see. Yeah.
So the largest of 3 is how?
Yes.
So the largest one here would be to the 3rd degree.
So 3, we had 3, because the last ones we had were 4, and we had 4. Yeah. Now, we're going to skip ahead a few, mainly because those next 2, the graphing calculator can just straight give us all 3, or all of them. Now let's look at this one here. So this one does have example 4. So, yep, right there, bottom of that page. where your left hand is. Yep. Yep. So it's the first one that says example 4, 10x to the 4th. Go on and type this in. Type this into the calculator. 10x to the 4th. 11x cubed minus 42x squared. Minus 24x, or 42x plus 7x plus 12. That might make a difference. X squared. 7x plus 12. Graph. Ten x to the 4th minus 11x cubed minus 42 x squared plus 7x plus y equals, let's look at it again. 10x to the 4th minus 11x cubed minus 42x squared. Plus 24 or 7x plus 12. Just needed 2 more terms. Was everybody able to get a graph that looks like this? Okay. So if we look at this here, we can see all the solutions, because there's four places where it crosses the x-axis, are all between -3 and 3. Yes? Because if we go over 1, 2, well, -2, 1, 2, 3. Second table. Well, this table does show all the possible places where it could cross the x-axis, and we don't have a single one where y is 0. Now, we do have solutions. They're just not integers. They're just not nice whole numbers. And this is where the rational zeros comes in. Because if any of those places where it crosses the x-axis is a rational number, a fraction, it will give it to us. So the first thing we're going to do is find the rational zeros. Now, I would advise putting the rational zeros above the problem on your worksheet, not below it, where you would normally write it. So above where it says example 4, where we would do problem number 5, I would put them there, because I realized the other day there's not enough room on the note sheets in that spot to fill this in. We still have to solve this. So I would write this above the problem, not below it, so you have room. Factors of p. Factors of the constant term is factors of 12. So we'd have 1 and 12. 2 and 6. 3 and 4. Factors of q, factors of our constant term, are factors of 10. So 1 and 10, 2 and 5. The number without a variable. And q is the number in front of the variable with the biggest exponent. So factors of p would be factors of 12. So 1 and 12, 2 and 6, 3 and 4. Q is factors of 10. 1 and 10, 2 and 5. Now, the nice thing with these factors is the first thing we're going to do is divide everything by the first factor of q. Divide all the factors of p by the first factor of q, which means we're just dividing everything by 1, which will just get us the numbers back, because 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. And 12 divided by 1 is 12. And we put the plus or minus. And once I do that, then I'm going to move on to 2. So we'll put plus or minus. 1 divided by 2, or 1 over 2 is 1/2. Then we'll move to the next one, 2 over 2. 2 divided by 2 is, do we have it listed? Yeah, we don't write it again. 3 over 2 is 3/2. It's not listed, so we have to put it up there. The next one, 4 over 2 is 2. It's already listed. 6 over 2 is 3. 12 over 2 is, we already have those. We don't have to list them. Now, you could type these in a calculator. You don't have to do these in your head. Just 3 over 2. It's 4 over 2. 6 over 2. 12 over 2. And if they reduce and they're already listed, we don't put them again. Now, part of the reason those reduced is, well, 2, 4, 6, and 12 all have a common factor of 2, so it reduced, yes? Does any of our factors of p have a common factor with 5? No, so it just means we're going to list these all back out. So we'll have plus or minus, well, we would have 1/5, plus or minus 2/5, plus or minus 3/5, plus or minus 4/5, plus or minus 6/5, and plus or minus 12/5. Because we're just dividing each of the factors of p by our 5 and the factors of q. It is. Let's go with purple. And our last one is 10. So we'll do 1 over 10, which is plus or minus 1/10. 2 over 10, 1/5, because they have a common factor of 2. 1/5 is listed. 3 over 10 is not listed because 3 and 10 just stays 3/10. 4/10 reduces to 2/5. 6/10 reduces to 3/5. And 12/10 reduces to 6/5. We already have them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. And since we have the positive and negative case, we have 32 possible rational zeros. But we've already seen on the graphing calculator, it did not cross at any whole spot, correct? Which means for us, let's get this yellow. One through 12, our nice numbers are gone. It's just by looking at the calc or the graph, I didn't cross at any of them. So they are all immediately thrown out. Well, we don't have 32 anymore. We have 20. We just got rid of 12 just from the graph. And we're going to use the graph and these together. So let's look back at the graph itself. Well, we do see that there are 4 spots where it crosses. Well, we have 2 spots that cross between 0 and 1 and 0 and -1, yes? Well, the signs are taken care of, but the main thing is, let's look and see which one of these are between 0 and 1. Well, 1/2, 3/2 is not. 1/5, 2/5, 3/5, 4/5, 5/6 doesn't, 12/5 doesn't. And our 1/10 and 3/10. All of these are between 0 and 1 and 0 and -1, yes? And I'm looking at the graph and seeing which ones kind of line up, which ones could possibly be one of these solutions. So pick one of these and we'll try it first. 1/2. Now, there's 2 ways we can go about doing this. One of them is synthetic division. We can set it up and do 1/2. We already have it typed in the calculator, yes? Do this here, second trace. Second trace. Trace is right there next to graph. Now, if you notice, what is the top entry on this? Calculate and then the one below it is. So what it's saying and what it's asking us and what we're telling it to do is I want it to calculate a value. And we said the value we wanted to try was 1/2. 1 divided by 2. Unfortunately, alpha y equals enter, our fractional form won't work when doing these, so we'll just have to write it as division. 1 divided by 2 is 4.25. But for it to be a solution, the y value has to be, so positive 1/2 doesn't work. So what can we try next? We can do negative 1/2. So second trace again. Let's do it again. Then do negative 1/2. So unfortunately, we can't do minus. We have to do the negative sign. And it is 0. So negative 1/2 is a solution. Again, I'm going to. Well, so we have one of the solutions, yes? Now we're going to do synthetic division. But out of the 4 solutions, the most that we need to find with the graphing calculator or the rational zeros is 2. We need to find at least 2. Because with our first one, we do this here. Negative 1/2 times 10 is negative 5. Negative 11 plus negative 5 is negative 16. Negative 1/2 times negative 16 is 8. Negative 42 plus 8 is negative 34. Negative 1/2 times negative 34 is positive 17. 7 plus 17 is 24. And negative 1/2 times 24 is 12, which gives us 0. Now we know the remainder for this has to be 0 because the calculator already told us it is a solution, and if it's a solution, the remainder has to be 0. Now the whole multiplication, addition going through this here, I'm not expecting you to do this in your head. I would do it in the calculator, let it do it for you, because it's just times, add, or subtract going through. So negative 1/2 worked. Now negative 1/2 will not work again, because if it crosses through, and we can see it did on the graph, it's only going to work normally once. So we need to look at others. Second trace value, 3/5, which is 0. And we could use this second trace and just start trying other values in. So we could have done it with 1/5, 2/5, 3/5, 4/5, and going on. Now 3/5 does work. And we can do this again. 10. Now again, at this process, I would definitely be doing this in the calculator because 3/5 times these numbers is not something that is easily done unless you're used to doing these. Because 3/5 times 10 is going to give us 6. Negative 16 plus 6 is negative 10. 3/5 times negative 10 is negative 6. Negative 34 minus 6 is negative 40. 3/5 times negative 40 is negative 24, which gives us 0. One reason I can do especially this one a little bit easier is because I did it 3 times yesterday. So a little bit of an advantage. But this is as far as we need to get it, because we've taken it from a degree 4 to a degree 3. From a degree 3 now to a degree 2. Since it is a quadratic, we'll put the variables back in. Remainder, negative 40 is our term without x, negative 10 is our term with x, and 10 is our term with x squared. So what we have is We have a quadratic. The quadratic formula will solve any and all quadratic equations. So if we can get it down to a quadratic formula will solve the rest. We don't have to continue looking through them for possible answer choices. Now at this point here, I will say, if any of these, you get to a point and notice that there is a common factor, especially a number, mainly a number of 10, in this one here, divide it out, get rid of it. Because if I divide everything by 10, it will make these numbers easier to work, because 10x squared divided by 10 is x squared. 10x divided by 10 is x. And 40 divided by 10 is 4. The answers that we would have gotten from 10x squared minus 10x minus 40 are going to be the same answers that we get from x squared minus x minus 4. I can tell you this here, we will not be able to factor x squared minus x minus 4. It just does not work. Because our square root of b squared minus 4 times a times c negative x minus 4? Because our 10, we'd have x squared minus x minus 4. Bless you. Unfortunately, we can't subtract x squared and x because x squared and x are not like terms, because we're multiplying it by itself. That's what the square prevents us from doing. Now, the last part that we have to do is just solve this here. Quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now our value of b in this case is negative 1. A is the number in front of x squared, b is the number in front of x, and c is our constant term. So I'll have negative negative 1 plus or minus the square root of negative 1 squared minus 4 times our a times c, which would be negative 4 times 1 times negative 4, all over 2 times 1. Questions on this so far? Questions on how we type this into the quadratic formula? Our negative negative 1 becomes 1. The denominator 2 times 1 is 2. Square root. Now we're going to type everything inside the radical into the calculator, which would be negative 1 squared minus 4 times 1 times negative 4, which is 17. So this is our b, a. Yeah, so here I didn't write it out. The number in front of x squared was 1. Number in front of x is negative 1. And c is our negative 4. Incidentally, square root of 17 doesn't simplify, it's a prime number. So the other two answers for this here are 1 plus or minus the square root of 17 over 2. And we also have that x is negative 1/2 and x is 3/5. So the rational root theorem gave us the two additional ones that we couldn't just find here. And then the other two were our 1 plus or minus the square root of 17 over 2. And that's it. Questions on this here? Yes?
You said the highest exponent, so which on this question would be 4.
Yes. We actually do have 4. Because here we do have 2, our negative 1/2 and 3/5. The plus or minus is telling us that.
Oh, okay, yeah. Okay, that makes sense.
No, you're good, because that is a good question.
Okay.
Because we do have 1 plus the square root of 17 over 2 and 1 minus the square root of 17 over 2. Now the graphing calculator can still calculate these second trace value, but we do have to put it in parentheses divided by 2, and we get this here. Now y equals 1.2 e to the negative 11th. We've seen this once before with I. But what that's saying, and I'll put this over here in this yellow color, 1.2 e negative 11 is really saying that we have 1.2 times 10 to the negative 11th, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This here, which for all case and purposes is 0. It's just a pixel error that it has in the calculation, so it's just a small rounding error that it's having to do. But for all cases purposes, that's 0. Yeah. So we still get 0 for this here. Questions on any of these here? Yes. Let's see here. 6x to the 4th. What was the rest of this one?
Plus 2x plus...
So we will start with this one tomorrow. So it crosses twice. Actually, I think it crosses 4 times, because if I remember this one from last year, that one little spot there does cross more than once. It's just kind of hard to see. Let's say negative 1 is 0, and it goes by 1/10. So now that we got it zoomed in, we can see that it does slightly come down below and then go back up. So it does. Let's see here, 0.001. Yep. Window, I'll zoom 6.